So there's that. There we go. All right. We're going to go up here. We talked about combinations the other day. Oh, is this going to give us 16? Shame. That was kind of one of the conversations. Who was at school yesterday? Mrs. Kuglin, Mrs. Waters, Mr. Guptill, Mr. Bellier. And they were like, oh, how many kids are coming to class? How many kids are coming to class? I said, well, my grade 10s are like 50%. And that's apparently the running kind of average, what a lot of people have said. But I said, geez, there was once or twice where we actually, I think, had 18 people online, which was pretty good. So, but the whole thing that the admin keeps talking to us about is like overloading, overwhelming. I know you guys are all seniors and you guys have all done this foolishness before, but like if you've looked, we're at the end. That's why I printed the probability stuff. But unless I make up a multiple choice test, which is a giant pain in the butt and not fair to most people, I trust most of you, but not all of you. Should try to like, well, I probably trust more of you than I would think, but I can't do a test at home. Here we go. Let's see. I gotta do it. Come on. Why is that not going down? If Joey joins, that's 18 of 18. He's not, come on. I am such a nerd. I'm sorry, we're not gonna do a whole bunch of examples today. He's busy. Well, we're still doing way better than most classes. So permutations and combinations are different. There are two buttons on your calculator. I'm going to do this. Can't remember which one was the one that actually gave me both at the same time. Ah, there we go. That's the one I want. So I think I went over a couple things in here the other day, order matters, and talked about them. So we're going to do part of 4.7. We're not going to do the whole thing because, well, I've rambled for Did Joey actually join? Yes, we have everybody. I love it. I just want to 18 of 18. So now I can, this made me pumped. If people drop out and whatnot, hey, I've had everybody here all at once. My day has been made. You guys are great. So what I want to do is go through a little bit of this. Then I will give you part of the homework. Then on Friday, we'll do the rest of it and give you the rest of the homework. And that, other than like my file here, if I go down, like I've got somebody, oh, come on, you piece of garbage. Permutations with repetition. I think those are just sections of book. And also like, oh, quiz Monday and all that stuff. So we'll deal with that later. So when we have one of these problems, order does, and it's not order factorial, does order matter? That reminds me, I have to go find something. Mrs. Babineau posted a great math joke on her Facebook a few weeks ago, and I keep meaning to share it. So we have to ask ourselves, does order matter? Or are the objects distinguishable? So if we're talking about people, the objects are distinguishable because even identical twins, they're different people. Well, for the most part, they act and behave slightly differently, so they are different people. So we'll see how far we get. Piano teacher and her students are having a group photo taken. There are 3 boys and 5 girls because this is one of these old-fashioned weird things. The photographer wants the boys to sit together and the girls to sit together in one of the poses. So they're going to do all sorts of them. This is just one very specific thing. How many ways can the students and teacher sit in 9 chairs for this pose? So we have different people, and there's specific things to the boys together and the girls together. To me, this is a yes. This is more a factorial sort of situation. So this one has a whole bunch of different things. Groups. In this question, essentially, we have 3 groups. We have the boys, the girls, and the third group, because 3 plus 5 is only 8, the teacher is part of this set of this set of possibilities. So if we have 3 things, we have the boys, the girls, the teachers. There's 3 groups. So how many ways are there to arrange this? Well, there's 3 possibilities to go in the first, like if we just pick to the furthest left. Well, then there's 2, because we could do boys, girls, teachers, girls, boys, teachers. This is 3 factorial, which equals 6 possible ways to arrange those 3 big groups. Within the boys, how many boys are there? Within that boys thing, there's 3. Because you could have boy number 1, boy number 2, boy number 3. Because they're not triplets, there's nothing there. You could have a tall person, a short person, and a short person. So within the boys, there's 3 choices to sit in the first chair, 2 and 1. Within the girls, let's change color. So that's 3 factorial as well. Within the girls, there's 5 of them, so 5 can sit in the first. 4, 3, 2, and 1, which is 5 factorial. And well, the one boring teacher, there's only one way to do that, or 1 factorial. So we have the big groups and the small groups. So the total arrangements, three groups times the boys. Well, there were 3 factorial ways to arrange the boys. The girls, there were 5 factorial ways to arrange them. And the old teacher, stupid face, 1 factorial. 6, 6. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 times 1. I probably could do that in my head, but $4,320 different arrangements. in that particular thing. And like these problems can get, oh my gosh, if there's my elementary school class that had 33 people. So you needed 11 people in each row. And it had to do with heights. You could make these super ridiculous, complicated things and how many possible orientations, and it's a lot. Now we'll simplify it a little bit. We still have 18. You guys are awesome. I love it. I can't wait to tell. Oh, my average attendance in Foundations 12 was like 15 out of 18 kids. We're better than the rest. All right, we're going to look at the word oranges. Is there any letters that repeat in the word oranges? No, but they're all different. So order matters, but there's not really a whole lot of stipulation. If there's no restrictions, well, how many letters are there? So that's just 7 factorial. If we just wanted to arrange them, 42 times, oh, I don't want to do that. Whoops. 7F T. Is it really going to be? It is. Oh my gosh, that's amazing. How to do a factorial on the Windows calculator is I literally have to push the exclamation mark key. So if there are 7 objects, you doorknob, there's 5,040 different ways to arrange the letters in the word oranges. What happens if the first one must be an N? Well, that has to be an N. There's only one N, so there's one way to put the one in there. There's one choice. How many choices are for the rest? Which is 6 factorial. Wait, 5 factorial is 120, 6 is 6. I think it's 720. Yes. Garbage trucks are here. The vowels must be together and in the order of OAE. So we have the vowels, and then there's 4 others. Consonants. But these are all together in one group, and it says in the order of OAE. So there's one way to do that. There's no other way to do that. So essentially this kind of breaks down into you have one group and 4 other things. So you can have this group. Well, the first space, there's OAE, or I don't know how to spell oranges, RNGES. So your first spot can be that OAE thing, or so there's 5 things that can go in the first spot. There's 4 because we've used 1, 3, times 1. Oh wait, 120. Now, if the vowels had to be together in any particular order, well, there would be 3 factorial ways to do that, which would make it multiply by 6. It would end up being almost the same as that one, but brains. I guess we're past Halloween and zombies. How many arrangements for the letters in the word brains, but the A and the I must be together? So we have the vowels, and we have B, R, and S, which there's 5 things. There's no repeats, so there's 5 factorial. But within the vowels, what are the 2 possibilities? AI or IA. So we have to multiply that by 2 factorial or 2. $120 times 2, or 240. Gosh, let us get back together sometime soon so we can actually let you try and think and discuss these, because you guys are all so quiet. The exact opposite to a kindergarten. Or, I don't know if any of you would remember Mrs. Smith. She used to teach at the school. She told me she has like grade 9 English, and her class is just a chaos storm. And I don't know, maybe your English classes are like that. Maybe when you meet with English teachers, you are discussing these things online. I don't know. This is all confusing. So I'm going to do... What is going on here? All sorts of foolishness. What is going on? I don't know. A standard deck of playing cards. Oh, look, 52 cards, 4 suits, 13 each. Maybe that's what I'm going to have to do at the beginning. Or I'll have to... What I really need is a great big poster that has the pictures of them. Wait. Mr. McEachran used to have a great big plotter. Maybe Matthews has access to it. Interesting. When you're dealt a deck of when you're dealt a hand of cards, does order matter? Nope. Whether you get ace 2, 3, 4, 5, or 5, 4, 3, 2 ace, you still have those cards in your hand. It's totally irrelevant. So, how many different 5-card hands can be formed? Well, N is 52. R is 5. Let's go here. 52, 5. Calculate. And I think we talked about this the other day. 2,598,2598,960. 2,598,960. So, in theory, there are 2,598,965 card hands in a deck of cards. So this actually leads into some of the stuff we're going to do in probability, which is awesome. How many different 5-card hands can be formed that consist of all hearts? Well, because we're talking about hearts. How many hearts are there? There's 13 hearts. If you want to get all hearts, you're taking 13 of those hearts and you're choosing 5 of them. So there's 13C5 hands, 5-card hands that only have hearts. So there's 1,287 hands that are only hearts. We're not talking about yet the probability, but we can essentially, because probability, if you've glanced at the notes, is the good outcomes over the total. Well, there's the number of 5-card heart hands. There's the number of total hands. So you can just divide those two and find the chances. If this is poker, getting 5 hearts all at once is actually a pretty good hand. How many different 5-card hands can be formed that consist of all face cards? How many face cards are there? Well, there's 3 per suit, 4 suits, so there's 12 face cards. This is something when we get to a test, if I don't have a fancy poster or anything like that, I will answer questions and clarify. A face card literally has a face on it. So the jack has a face, the king has a face, the queen has a face. A 10 is not a face card because there's no face on it. So in this case, there's 12 face cards. R is 5. A little bit, I mean, in terms of card game, totally irrelevant because, oh, I've got 2 kings, 2 queens, and a jack. Well, that doesn't do anything for you. 12. So there's 792 of those. Now, how many hands are there that are all kings? Well, there's 4 kings. There's 4 to take, so it's 4C4, which is 1. But you have another card, but that's a whole other thing. That's something we'll talk about in probability. How many different 5-card hands consist of 3 hearts, 2 spades? One like this, we have to consider hearts. Oh. And spades separately. Hearts. How many hearts are there? 13. How many are we choosing? If it's 3 hearts, 13C3. What the heck just happened? 286. There's 13 spades as well. We want 2 spades, which is going to be a slightly smaller number. 78. So there's 286 groups of 3 hearts. There's 78 of 2 spades. How many are going to be of those? Well, we want 3 hearts and 2 spades. So we're going to take 286. We're going to multiply that by 78. I can do that in my head. 22,300. Hopefully that is somewhat logical. I'm just not comfortable, so I'm just going to how many 5-card hands consist of exactly 3 hearts? Is that the same idea as this question? Similar. This one says the other 2 cards had to be spades. Is there any limitations on those other 2 cards? In this case, no. Come on, brain. Red. So we've got hearts. And because that says exactly 3 hearts, if it said at least 3 hearts, then it's a stepwise calculation. Because if you have 3 hearts, you could have 4 hearts, you could have 5 hearts. Those, all of them have at least 3 hearts. But in this case, we've got 13 hearts. We're choosing 3 of them, which we've already got as 286. Well, it's a 5-card hand, so we need 2 more. The question is, what's the N for this one? Could the other 2 cards be spades? Sure. Could they be diamonds? Yeah. Could they be clubs? Could there be one of each? So essentially, we're taking 2 cards from those other 3, which 13, 13, and 13 are 39. $741. And means we're going to multiply those 2 because we have all of those ones plus all of those ones. And it makes sense to me, although I don't remember, 926. And there's more hands that there's no restrictions on the other 2 cards than there would be if there is restrictions. So I'm going to stop here for today because A, it's 1:30, and B, I don't want to rush everything. So there's 1, 2, 3, 4 examples. Cards. What I would like you to try today, 3 to 8, I think is all of those. Cards, tickets, starting lineups, flags. Oh, 3, I guess, was up there. Technically, you could look at number 2, number 1, but we'll start with those ones for Wednesday. Because we're in a rush, but we're not in a rush. So that's where I'm going to stop today. I'll save that. I'll post everything and do all that. Thank you all for showing up and coming, however many of you actually paid attention. I'll post later this week. I'm like 95% sure, unless like, hey, you never know. Y'all could be back on Monday, then it won't matter. I didn't see it, but I hope. Let's cross our hands that one particular person who lives down the road from me, or well, down the hill from me, comes to some senses. So